Good morning. Welcome to episode number 47 of the ZOOMTOWN experiment. For today's video, we're going to take a look at telemetry. If you've ever watched circle track racing or NASCAR, F1, Indy type car racing, the race cars often provide data back to we'll call it a central computer for the team. It's called telemetry data. And that data will give them all kinds of information about how fast they're going, engine temperatures, engine performance, anything at all that they want, they'll feed it back so that the car can be monitored remotely. And that's what we're doing in this particular episode, or we're talking about it. We'll go to the overhead real quick, and I'll just kind of quickly go through the three primary points I want to make. The Zoomie's position must be tracked at all times. This is used in a system that will help prevent accidents at controlled intersections and when crossing traffic lanes. As you can imagine, if the Zoomie is making a left turn, in our world here in the United States, we would be crossing over the oncoming traffic lane when we perform a left turn. Well, we need to make sure nothing's coming at us when we do that, or it's going to hit us real good right square in the nose. So that's part of what this process and system is going to be doing. The Zoomie updates and reports its position many times per second. The actual frequency of reported data will be something I need to tune and tweak for the best overall performance between the Zoomie and over at the scheduler on how fast it can receive the data and update all the sprite positions on the display. And that has to happen for all 16 Zoomies simultaneously. So I don't want to overload the system, so it's going to be a balancing act, and that'll be developed over the next month or so. The scheduler takes that positional data and moves a sprite or icon of the Zoomie on the layout map. Now, over at the scheduler software, you saw the layout of ZOOMTOWN, graphical representation of the layout, with the roads, the parks, the driveways, everything about it. And there are little Zoomie sprites. They're just a simple rectangle, blue rectangle, I believe it is, and with the ID number printed in the middle of it. Well, that will move in unison with the physical Zoomie that's moving around on the physical layout. That's the whole function we're trying to achieve here. It is not perfect right now. This is just my first go at it. I've got some lag issues in it, and I don't know where those are. They could be happening at the Zoomie, could be happening in MQTT, it could be happening on the scheduler not being able to update fast enough. I need to work into that, but as I observe it over the course of the next month or so of testing and all that, I should be able to narrow down those slight lags. Here in the Zoomies program, we'll take a look at a couple of code elements. The first thing we're going to look at is the actual function that sends the telemetry data. I'm taking this data that is being updated constantly in the Zoomie, the global XY position, the global heading, and the current road number that it's traveling on. I then check to see if it's changed at all from the last time I've sent this data. If it has changed, we will then pack a message that contains that data. We'll print it out here locally so I can observe it down in the shell, and then we use the MQTT client and publish that data to the scheduler. The scheduler subscribes to those topics, so it gets the data and then breaks it apart into a data format that's useful over there. Then we are going to look at this area here, which this is in one of the motions that we perform, FLS. It's in that routine. And within there, I have added a lot of code for each of these different motion types I've added the code that will calculate the global position. Up to this point, we've really only been concerned about position along the distance of a road, or along the length of a road, or the distance, say, to the barrier or garage door. Well, I needed to get that into global coordinates so that it correlates with the physical position on the whole layout. Global coordinates are on the layout, with the origin point being in the far left corner. And this is how I go about it, and it varies a little bit between different types of motion in how I go about processing and calculating that global position, because some motions perform incremental move, only a distance and direction. Others perform an absolute move, where we move to a very specific point along the road, and that also in turn handles the direction. So we'll see this sort of code in each of the motion functions. So I'll go down to another one. Here's a simpler version of what I had to do above. If you're following along in the code, of which I'll be providing online in our companion website, makingstuffwithchrisdayhut.com. You can look for this vid 47 as the flags of where to look in the code. And I got one more area I think I want to show you. Down here within the main loop, let me get back to the top of it. This is our main loop, still running at 6 millisecond regulated, although I haven't tested that in a while. But one of the functions, and I was just on it right here, is our MQTT comms. And if the MQ counter, this is just an internal counter that counts the number of our main loop cycles. So after 20 cycles, so 20 times 6 milliseconds, that is our frequency. For right now, I've got it set, I believe it'll be lower than where I really want to get eventually, but I got to start somewhere. And this just simply says send the telemetry data, and then it checks the message for messages again, resets this counter back to 0, and then it'll count back up to 20. So that's how I get the data from the Zoomie as it's moving over to the scheduler. And again, this is all about helping with traffic control and collision avoidance. I knew all along from the beginning that had to be a very critical function that's incorporated in this whole experiment. So with all of that covered, we'll head over to the scheduler and I'll demonstrate what's going on over there. Now the first thing what we'll do is we'll go through and I'll show you in the code what we're doing with regard to our positional data as it comes in from the Zoomie. So we will search through the code. Okay, this would be our message processor this is the callback function that MQTT will use when it receives data via MQTT. So it's typically called on message. The data would come in. We're going to update some counters. And then what I want to do is take that data that came from the Zoomie in the format that was useful there and put it into a list, which is much more useful here. And that would contain the ID number of the Zoomie that sent it, the X and Y position in global coordinates, X and Y position in pixel coordinates, the heading, and then the road number or road ID, or it could even be a destination. So that's the data coming in. And that also works, that function calls the expand telemetry message, where this is actually pulling out the raw data and breaking it up into very simple local variables that are returned at the end of the function. And this is more about floating, formatting floating numbers and strings, etc. So this is really the workhorse to get the data into the scheduler software. And then this is the function that runs to update the position. It runs every cycle of the Pygame frequency that I've set in it. I think I'm at 15 frames per second or something like that. Again, that's another one of those adjustments I'll have to tweak based on actual performance when we're running tests. But this function is very simple. It just, for each of the Zoomies, it just moves the Zoomie to the position that we've just put in there from that MQTT message. And then one more place in the code is down here. Oh, we got to go a couple more times here. It's defaulting to start at the top. This is within what would be referred to as like the main loop on a Pygame program. And here that function is called every time this main loop cycles, and just simply calls update all sprite positions. It'll update the list, and then finally it'll draw the sprites in their current location. All around, this is relatively simple things. The math over there to calculate the coordinates and all of that, but to get all this data to perform is going to be the real challenge. But let's go ahead and demonstrate what this will look like. This you've seen before. This is the graphical layout. We've been demonstrating how to get from position to position. Right now this is all still in manual or programmer mode. And we're currently physically in destination 31, and we'll run up over to destination 17, which is way over there, or as you can see here on screen. So I'm just going to say start here, go up road 21, over on road 4, go up on road 19, go to road 6, and then park in destination number 17. Now I see the full list of these roads. They're highlighted in red. I see the start and the ending destinations. I will do a process trip plan, which will take all those little pieces of data, convert it into a trip plan. We will simulate it, which is nothing more than placing this icon at the start or end point of each line. All around, that looks acceptable. So now I will hit select Zoomie and run. And I forgot to start the Zoomie software, so bear with me 1 second. Okay, hopefully the Zoomie is now ready. I see the LED blinking green. That's a good sign. We will send it. I've got a fast red flashing LED. That's another good sign that the trip instructions inside the Zoomie, and now I've got to hit cycle start on my control panel here. And I'll probably have to guide the wire as it moves along. And as you can see, it's exhibiting some lag in there, and that is what I need to refine in the coming weeks here. I do need to have that a lot tighter, and at this point I just don't know where that lag is, so through observation eventually I'll get that one tracked down. But that's a demonstration of the motion tracking. I would like to point out, this is not a true absolute tracking system, meaning it's guaranteed to be in this exact spot. Things could cause the Zoomie to get off track, and I would not know it in this tracking algorithm or methodology. And that's where eventually, if needed, I will have to go to another form of tracking system, and that was the ZTS, Zoomie tracking system I had talked about in an earlier episode, where I would have an overhead camera that can see the whole layout, and I'm doing object tracking for each of the Zoomies, and then using that as true absolute position data. I'm hoping to not have to go down that road, because that's going to introduce a massive amount of additional work and cost to get that all to work properly. But until then, I think we're good to go and move forward with this. Back on the Zoomie software, I wanted to show you the output or data output as these telemetry messages are sent over to the scheduler. This is the actual data and the format of that message I'm sending. I'm saying I'm Zoomie 3, Z3, we're at 4 inches, 86.34 inches, and the road we're on is 22, etc. So that is the data that's going from here over to there. And in this particular move, you can actually see which axis is moving right here. Oh, and by the way, the W there is the heading. It's going west. So from your viewpoint, looking at the overhead camera, it is moving to the left. But you'll see the positional data being altered right here in these codes. So we'll look at that as the incoming data. This is what the data will look like coming in from the Zoomie. These are the messages that we're receiving. It would be this data right here, but that isn't the raw data coming in. That's refined a little bit. And then I pack it into the list, internal for the scheduler software to deal with using this line right here. So we go from this to this, and that's the data I work with within the scheduler. And what we've got here is Zoomie number 3. This is the X and Y coordinate in pixel coordinates on the screen. This is the X and Y coordinates that are global. And this is the heading that it's currently moving, in this case east. And the only time we moved east was when we were backing out of the driveway. So there is no road number. But you will see the x-axis values continue to increase as it backs out. Now here we're moving north, and the numbers are moving up on the y-axis. So that's that tracking information. So with that all covered and how this process will work, both at the Zoomie and over at the scheduler, you can perhaps now see how I can, with that data in the scheduler can look at all those positions of every Zoomie, and then when a Zoomie is stopped or needs to cross traffic, it can ask permission. The scheduler can look at that data and say, yeah, it's okay, there's nobody coming at you and nobody in the area. Or, no, don't go yet, we got traffic coming. And then the Zoomie will just sit there waiting until he finally gets the go signal. So this one's going to be a lot of development to refine this process. As you saw, there was lag time in it and so forth. Now, moving forward from here, the project's getting more and more complex, and the Zoomie and the scheduler have to work together in a lot of this development. So I'm going to try to keep the videos on a much smaller topics as we move along, because I do need to develop now about 4 or 5 different functions almost simultaneously. But to explain all of them at one time will just be a ridiculous amount of time. So in the future videos, I'm hopefully going to be able to keep them concise about 1 or maybe 2 topics or features as we move closer and closer towards running our real experiments. That'll wrap it up for today. Thanks for watching, and I look forward to seeing you in the next video.